Hello, my name is Nisa Kaini with student ID number 21130110056 from the 4C class. So, this is the final semester exam project video for English format. Good morning, student. Welcome to the English class. I am Nisa Ayokhaini. You can call me Miss Nisa, and I will be your teacher for this subject throughout the semester. Alright, before we start today's lessons, there are some essential announcements I need to make. First, making sure you have your English textbook and complete writing materials. Second, remember to activate your microphones and camera when we interact in this class. This will help you communicate effectively. Lastly, I have prepared the teaching materials that we will discuss today. But before that, please fill in the attendance list that Ms. has ready in the Zoom chat column. Okay, the topic for today is the limit of algebraic functions. Let's begin. I will share the presentation slides and go to toast them together. Okay, student, if you have any question, feel free to ask. Let's make this class interactive and enjoyable. Happy learning, students. Okay, the topics we will discuss in today's meeting are four. The first one is about the definitions of limit. The second one is about the substitution method. The third one is about the factorization method. And the fourth one is about the real-life applications of limits. Okay, the material is about definitions of limits. The definitions of limit in mathematics refers to a value that a function or sequence approaches input or index approaches certain point. It describes the behavior of a function or sequence near a particular input or index value. Formally, the definitions of limit is as follows. For a function f of x defines on a domain D, the limit of f of x as x approaches a specific value, say A, denotes as limit x approaches A of f of x equals L. X is the independent variable, A is the approaching value, f of x is the functions, L is the limit value as x approaches A. Okay, the methods we will discuss in today's meeting are two methods for finding the value of a limit. The first is the substitution method, and the second is the factorization method. Okay, the direct substitution method is used when we can directly substitute the limit value for x into the functions without encountering a division by zero or other indeterminate forms. For example, if we observe limit as x approaches 2 of 5x minus 2 equals x is obtained by substitutions x equals 2 into 5x minus 2. Okay, example 1. To determine the limit as x approaches 2 of x squared plus 2x all over 2x plus 1, the solution is we can use the substitution method. Substitution x equals 2 into the expressions. We have limit as x approaches 2 of x squared plus 2x all over 2x plus 1 equals 2 squared plus 2 multiplied by 2 all over 2 multiplied by 2 plus 1. Simplify further, we get the following: 4 plus 4 all over 4 plus 1 equals x over 5. Therefore, the limit of the expressions as x approaches 2 is x over 5. Okay, example 2. To determine the limit as x approaches negative 2 of negative x cubed plus 2x minus 2 all over x minus 1. The solution is we can use the substitution methods. Substitution x equals negative 2 into the expressions. We have limit as x approaches negative 2 of negative x cubed plus 2x minus 2 all over x minus 1 equals negative multiplied by negative 2, q plus 2 multiplied by negative 2 minus 2 all over negative 2 minus 1. Simplifying further, we get the following: negative multiplied by negative x minus 4 minus 2 all over negative 3 equals x minus 6 all over negative 3 equals 2 over negative 3 equals negative 2 over 3. Therefore, the limit of the expressions as x approaches negative 2 is negative 2 over 3. Okay, next material about factoring methods. Factoring method is proper when dealing with the limits of algebraic functions. It involves factoring the functions to simplify the expressions and cancel out common factors. This allows you to evaluate the limit more easily. To illustrate the factoring methods, let's consider an example. Example 1. Determine limit as x approaches 3 of x squared minus 9 all over x minus 3. The solution is step 1. Simplify this function if possible. Notice that the numerator x squared minus 9 is a difference of square, which can be factored as x minus 3 multiplied by x plus 3. The denominator is already in factor form. Therefore, we have a limit as x approaches 3, x minus 3 multiplied by x plus 3 all over x minus 3. Step 2. Cancel out common factor. Since we have a common factor of x minus 3, in the numerator and denominator, we can cancel them out. Limit as x approaches 3 of x plus 3. Okay. Step 3. Evaluate the limit. Note that the function is simplified. We can directly substitute the limit value into the simplified expressions. 3 plus 3 equals 6. Therefore, the limit as x approaches 3 of the given function is 6. Okay, example 2. To determine the limit of the expressions x squared minus 9 all over x cubed minus 27 as x approaches 3, we can use the factorization method. First, let's factorization the numerator and denominator. X squared minus 9 can be factored as x minus 3 multiplied by x plus 3. X cubed minus 27 can be factored as x minus 3 multiplied by x squared plus 3x plus 9. Now we can simplify the expressions. Limit as x approaches 3 of x squared minus 9 all over x cubed minus 27 equals the limit as x approaches 3 of x minus 3 multiplied by x plus 3 all over x minus 3 multiplied by square plus 3x plus 9. Since both the numerator and denominator have a common factor of x minus 3, we can cancel out limit as x approaches 3 of x plus 3 all over x squared plus 3x plus 9. Now we can directly substitute x equals 3 into the simplified expressions. 3 plus 3 all over 3 square plus 3 multiplied by 3 plus 9. Simplifying further, we get the following. 6 over 27 equals 2 over 9. Therefore, the limit of the expression as x approaches 3 is 2 over 9. Okay, students, the next material about real-life applications of limits. The utilizations of limit and functions in everyday life is diverse. Okay, number one, computer science. Limits play a role in analyzing the efficiency of algorithms and computing system. The analysis of algorithms complexity often involves taking limits as the input size approaches infinity to determine the algorithm's runtime behavior. Limits are also used in tasks like image processing, optimizations problems, and simulations modeling. Okay, number two, finance. Limits are utilized in finance to analyze financial derivatives and risk management. The concept of a derivative involves taking the limit as the change in variables approaches zero, enabling the calculating of instantaneous rates of change in financial instruments. Limit also help in assessing investment strategies and analyzes economics models. Okay, number three, medicine. Limits are employed in medical fields to understand biological process and drugs doses. Pharmacokinetics use limits to determine the concentrations of drugs in the bloodstream over time, leading to proper dosage strategies. Limits are also used in modeling psychological processes, such as the rate of change of the drug's effects on the body. Okay, next, number 4, genetic. Genetic use limit to analyze genetic inheritance pattern and population genetic. In population genetics, limits help determine the frequency of different genetic types or causes in a population over generations. Okay, number 5, economic. Limits are applied in economics to analyze marginal quantities. For instance, the product's marginal can be determined by taking the limit as the amount approaches zero. These informations help business make decisions regarding production level and principal strategies. Okay, number 6, energy and power system. Limits are used in analyzing electrical power system to determine maximum power transfer, voltage stability limits, and fault during calculations. Okay, number 7, art and designs. Limit can also be embedded creatively in art and designs. Artists and designers might intentionally limit materials, color, or dimensions to inspire creative and explore new artistic expressions. Okay, number 8, stock market analysis. Limits are employed in financial analysis and stock market predictions. Traders and investors use limits to set results for buying and selling stock based on price fluctuations, and market trends. Number 9, transportation planning. Limits are employed in traffic engineering and transportation planning. Traffic flow analysis use limits to determine traffic capacity, congestion level, and optimal traffic signals timing. Alright, students, the class time for today has come to an end. Thank you for your active participation in this class. You have shown incredible dedications and enthusiasm for learning. I'm very proud all of you. Remember to always complete the given assessment and continue to develop your English language skills. If you have any questions or need additional help, don't hesitate to contact me. Okay? May you success in your learning journey. See you at your next meeting. Have a restful break. Okay? Goodbye.